A statement from Brian Cox could be astonishing, shining like a second sun since it's only 600 light-years away. The red supergiant Betelgeuse could potentially explode tomorrow. Recent observations show that Betelgeuse has darkened significantly and is quite unstable. Scientists around the world are eagerly anticipating this event, and when Betelgeuse does explode, it will be visible to the naked eye from Earth. The explosion could shine brighter than the entire galaxy for several seconds, and even weeks later, we could still see the remnants of the supernova. So, what will happen when Betelgeuse explodes? According to astrophysicist Brian Cox, we will witness a brightness so intense that it will appear as a second sun during the day. We might be momentarily blinded by its brilliance, and if the explosion occurs at night, it will illuminate the sky as brightly as daytime for a brief period. While it is certain that Betelgeuse is approaching its explosion, soon on a cosmic scale could mean anything from 100,000 years to just one day. The intriguing aspect is that Betelgeuse might have already exploded. The light from that explosion would take 600 years to reach us, meaning we will only see its dazzling brilliance 600 years after the actual event. This concept illustrates the incredible dynamics of the universe. The anticipation of witnessing this supernova is exhilarating. We have been closely monitoring Betelgeuse's changes, especially during 2019 and 2020 when it underwent a significant dimming event known as the Great Dimming. This sudden drop in brightness sparked speculation that the star was nearing its explosion. Many scientists expected the star to brighten shortly before the final event. Eventually, they determined that the dimming was caused by a massive release of dust, obscuring some of the star's light. Betelgeuse, which is about 1,000 times larger than our Sun, has experienced considerable material loss. The dimming resulted from both the dust cloud and the star cooling. In March 2024, the American Association of Variable Star Observers reported that Betelgeuse experienced another decline in brightness of about 0.5 magnitudes. Researchers have been anxiously tracking this dimming since late January, as any unusual change could indicate an impending explosion. However, the precise state of Betelgeuse remains a mystery. The hypothesis surrounding its binary star nature suggests that while it is clear that Betelgeuse is heading toward a supernova, its exact stage in this process is uncertain. Betelgeuse does not behave like a typical red supergiant, and some of its characteristics do not fit the standard model. Some scientists propose that Betelgeuse may be the result of two smaller stars merging. If this is the case, we wouldn't just be observing one aging star on its path to becoming a supernova, but rather two. This rapid rotation and the presence of heavier elements like nitrogen in its atmosphere are atypical for a standard red supergiant. Simulations conducted by astronomers suggest that Betelgeuse could have initially formed from a binary system where one star drew mass from the other, leading to their merger. This process would disrupt the internal structure of the newly formed star and push heavier elements toward the surface, accounting for the unusual nitrogen concentration. The merger would also increase the star's rotation speed. Normally, red supergiants rotate much more slowly. However, the quick rotation observed could be an optical illusion caused by surface activity, making it seem as if the star is spinning faster than it actually is. The true state of Betelgeuse remains difficult to assess. The only scientific certainty at present is the movement of violent convective currents pushing billions of tons of material to the surface, making the core increasingly unstable. Betelgeuse is likely in the late stages of its development and is suspected to be undergoing the carbon-burning phase, which typically lasts around 1,000 years. Once this phase concludes, Betelgeuse could explode within decades rather than centuries, as previously thought. The renewed dimming observed in 2024, along with the ongoing fluctuations in brightness, might be the first signs that the star is nearing its end. Betelgeuse holds particular significance for us. It is not just any star. It is one of the brightest in the constellation Orion and has been of great importance to humanity since our species first gazed at the night sky. Betelgeuse likely expanded into a red giant over the course of millions of years. We have become increasingly aware of the characteristics and fate of Betelgeuse. The earliest mentions of this star date back to ancient Egypt and Mesopotamia, where it was revered as one of the brightest in the night sky. In the Middle Ages, astronomers like Tycho Brahe referenced Betelgeuse in their star catalogues, describing it in the 16th century as prominent and reddish, and pondering its significance. The systematic study of Betelgeuse began in the 16th and 17th centuries with the advancement of telescopes. Galileo Galilei, a pioneer of modern cosmology, observed Betelgeuse and analyzed its brightness variations in detail. As telescopes improved in the 18th and 19th centuries, more detailed observations became possible. William Herschel emerged as a significant figure during this period, classifying Betelgeuse as a variable star, one that changes in brightness over time. A major breakthrough in our understanding of Betelgeuse occurred in the 20th century with the advent of spectroscopy. In the early 1900s, astronomers began to investigate the chemical composition and temperature of distant stars. Spectroscopic analysis revealed that Betelgeuse is a red supergiant in the late stages of its evolution. Edwin Hubble, renowned for discovering the expansion of the universe, also contributed to the study of Betelgeuse in the 1920s by employing newly developed astrophotography techniques to explore its size and structure. The invention of radio telescopes in the 1950s and 60s marked a new era in astronomy, enabling observations of Betelgeuse across various frequency ranges, which provided new insights into its physical properties and atmosphere. Then, in the 1990s, the Hubble Space Telescope transformed our observations of Betelgeuse's surface, allowing us to see its irregular brightness fluctuations for the first time. Subsequent studies have identified several recurring cycles of these variations. Since the start of the 21st century, advancements like interferometry have allowed astronomers to make highly precise measurements of stellar surfaces. Observations from large telescopes in Chile have provided stunning images of Betelgeuse's turbulent surface activity and enormous convection cells. However, our understanding of Betelgeuse is still relatively new, complicating our ability to make accurate predictions. Recent observations in 2024 indicated another significant dimming, supporting theories that Betelgeuse may be heading toward a supernova explosion. Modern technologies, such as high-resolution spectroscopy and computer simulations, now enable us to track Betelgeuse's current state and future evolution. While Betelgeuse remains a subject of intense scientific study, its exploration illustrates the progress of cosmology and humanity's capacity to unravel the mysteries of the universe. What do we truly know about supernovae? Despite our scientific confidence, especially regarding the cosmos, many theories and assumptions remain speculative. Our grasp of supernovae is just as limited as our understanding of Betelgeuse. For centuries, humans have witnessed the cataclysmic explosions of dying stars, often misinterpreting these events. The earliest recorded observation of a supernova occurred in 185 AD when Chinese astronomers noted a guest star in the constellation Centaurus, which shone brightly for 8 months before disappearing. In 2006, the most luminous supernova ever recorded was observed by astronomers worldwide. Historical records from China, Japan, and the Middle East indicate that this supernova, known as SN164, was so bright it cast shadows at night and was visible during the day. Scientists predict that Betelgeuse could shine similarly. Another well-documented supernova took place in 1054, when astronomers in China and the Middle East noticed a new light source in the constellation Taurus, which later became the Crab Nebula. In 1572, Danish astronomer Tycho Brahe observed a supernova in the constellation Cassiopeia. His detailed records contributed significantly to our understanding, as he was among the first to note that the sky is not constant, as Aristotle had claimed, but subject to change. Johannes Kepler later introduced the concept of the supernova in 1604, having observed a celestial nova that he believed represented the birth of a new star. Kepler's supernova was the last observable supernova within the Milky Way visible to the naked eye. Essentially, we have only recently begun to understand what supernovae are since the introduction of spectroscopy in the 19th century. The study of dying stars and their explosions remains a rich field of inquiry, revealing ongoing secrets of the universe. It is important to recognize that the investigation of supernovae and stars like Betelgeuse has significant implications for our understanding of the cosmos. Each supernova provides crucial insights into stellar life cycles, the formation of elements, and the dynamics of massive explosions. When a star goes supernova, it disperses heavy elements into space, essential for the formation of new stars and planets, contributing to the chemical evolution of galaxies and influencing the creation of future stellar and planetary systems. Moreover, observations of supernovae help astronomers refine cosmic distance scales, enhancing our understanding of the universe's expansion rate. For example, Type Ia supernovae, which occur in binary star systems where one star is a white dwarf, serve as standard candles due to their predictable luminosity. By comparing the observed brightness of these supernovae to their known intrinsic brightness, scientists can determine the distance to their host galaxies, crucial for calculating the universe's expansion rate. Technological advancements in cosmology, including space-based observatories and modern spectrometers, have enabled more detailed investigations of these celestial phenomena. Instruments like the James Webb Space Telescope, JWST, are expected to provide exceptional views of distant supernovae and their remnants, offering new insights into the early universe and the formation of the first stars. Additionally, studying supernova remnants like the Crab Nebula provides valuable information about the aftermath of these explosions, serving as natural laboratories for examining the behavior of matter and energy under extreme conditions, thereby aiding in the validation of theories about cosmic evolution and fundamental forces of nature. In summary, the ongoing study of stars like Betelgeuse and their resulting supernovae represents a dynamic field of research with the potential to unveil deeper mysteries of the universe. Each discovery and observation not only expands our knowledge but also fuels our curiosity about the complex and ever-evolving cosmos we inhabit.